In this video, we're going to have a discussion on IAL Mechanics 1. This is a prediction of the main areas, main concept, very common question that are usually asked in mechanics. So we need to dive in so that we can be able to see what you need to work on. And if you're new to Proflearn YouTube channel, consider subscribing and also sharing this particular channel to your friends so that they can be able to join and also benefit from the same. So I've gone through some questions of this particular prediction. So we are going to dive in and check how do you approach the questions and how do you ensure that you maximize on the total marks awarded. If you like to download this paper, you can be able to download it from our Patreon page. Join and then you can be able to access that. Now let's look at it. What we need to remember is that mechanics 1 is 75 marks, and that is going to take you 1 hour 30 minutes. And in this paper you will use G to be 9.8. Yeah, so don't forget that. Now we have question 1, and question 1 here we are told about two particles. We are told about two particles A and B that have masses m and 3m respectively, and then the particles are connected by a light inextensible string. So it's inextensible, so that if one moves, the other object also will move at the same acceleration. So the string is not stretching. Now, initially A and B are at rest on a smooth horizontal plane with a string slack. Yeah, the string is slack. The string is slack like this. It's not stretched. Just slack. Yeah, and particle A is then projected along the plane away from A with the initial speed u. Given that the common speed of the particles immediately after the string has become taunt is s. Yeah, so in part A we are asked to find s in terms of u. Find s in terms of u. So what I did here, in the process of working out this question, I decided to identify A here and we have B. Immediately A start to move at the speed of u. This was at rest. So we are going to use the concept of momentum before collision is equals to momentum after collision, which is the conservation of momentum. So total momentum before collision is going to be u time m times u, because initially before they started moving together, this was moving at u, so momentum will be mass times u, but this will be having zero momentum because initially it was at rest when this was moving. So immediately that now it became taunt, that's when now they move together. Now, because they move together at the same speed, then we are going to add the two masses for after collision, the sum of the two masses times the distance, the speed s. So if you work it out, you are going to get your answer translating to what? This answer translates to u over 4 all, which is the same as for 0.25. 0.25. Now find in terms of m and u the magnitude of impulse exerted on A immediately after the string become taut. Now what we need to realize here is that impulse is equal to the change in momentum. So impulse exerted on A is equal to the change in momentum of A. And in that way, change in momentum is given by the formula momentum, final momentum, minus initial momentum. So that is the approach we are going to use in this particular case. So that's what you can see. I decided to say that impulse is equals to final momentum minus initial momentum. We have already gotten our S, speed after, is u over 4. So we can say now for change in momentum for A is mass of A times the final speed of A minus mass of A times the initial speed of A, which is u. Yeah, initially it was moving at u. So meaning that if you work it out, you are going to get your answers negative 3 over 4 mu. But now remember, the question is asking you what? Magnitude. Magnitude means we are going to ignore the sign. Looking at question 2, we are told that two particles P and Q have masses 2m and m respectively. The particles are moving towards each other. So one is coming this way, another one is coming. So meaning one is having negative speed of velocity of the other. Yeah, so the particles are moving towards each other in opposite direction along the same straight line on a smooth horizontal surface. So which means now we don't have the aspect of friction at this point. The particles collide directly. Immediately before collision, speed of P is 3u and speed of Q is 2u. Immediately before collision, speed of P is 3u and that of Q is 2u. The magnitude of impulse exerted on Q by P is 5. So the magnitude of impulse exerted on Q is 5 mu. So this means that the change in momentum of Q is going to be 5 mu. But the impulse exerted by Q on P will be negative 5 mu. It will be they will be equal but acting in opposite direction. So that's why you can see for particle P, I said the impulse, because we are supposed to calculate the speed of P immediately after. So for particle P, because P exerted an impulse of 5 mu, it will mean that the impulse P is going to experience will be negative of that. Yeah, so that's why you can see I've basically used this value that I have here as now with a negative sign. Now that becomes the impulse of P. But remember, the mass of P was the mass of P was 2m, and the final speed, we can let this final speed of P to be v. So we can say now v minus 3u, because initially it was moving at 3u. Now if you work it out, you are going to get that your value is going to be what? Negative, a half u. That is now the speed. That is now the final speed of particle P. And also we in this question, I assumed that the particle Q is going to move finally with a final speed w. So in that way, when you are supposed to find the speed of Q immediately after collision, you will take its impulse or the change in momentum to be 5 mu is equals to m into w minus negative 2u. Why are we having this negative? Because the speed the speed of they were moving in opposite direction. So if we take the speed of P to be positive, then the speed of Q will be negative 2u. Yeah, so because it will be moving in the opposite direction to P. So some of those kind of basic nitty-gritty information and details, you have to be very keen with them, and in that way you will be able to earn all the marks. So moving on to the main area, let's see Now, if you work it out, you are going to realize that W is going to reduce to 3U. So we're going to get the, in terms of U, it's going to be 3U. And now let's look at forces. And in this case, we are having two forces acting in shown there, Q and P. And then we're going to have the resultant force. So in part A, we are told the resultant force is or has a magnitude of square root of 129. And we're supposed to find X, and then finally we find the angle between Q and the resultant, giving our answer to the nearest degree. So this question, alternatively, you can be able to use the concept of components. You find the horizontal and the vertical component of each of the forces, and then you can be able now to combine. But for my case, I decided to go take life easy, and I decided now to use cosine rule. Now, upon using cosine rule here, you can see now this triangle that we have, because these vector forces are vectors. Okay, so I think I need to display something here. Yeah, so if I want to draw a vector diagram of this, I can shift this force here. Force P, I can shift it here. And once I've shifted it there, like that, this is going to be our force P. Then the resultant force will be this here. We shall have R. And in that way, we shall form what? We shall form a triangle. And this is a vector triangle that we can be able to use. This vector triangle I'm talking about here, I've already done it down here. So we have X acting that direction, the angle 30 degrees, and then we have 5 root 3, then the resultant R is that. So if you apply cosine rule, you are going to check, because X is the one that you are looking for. Yeah, so you can say R squared is equals to X squared plus D squared minus 2X 5 root 3 cos 30. Just cosine rule. Now, once you've applied cosine rule, you are going to form a quadratic equation. Yeah, after simplifying everything, you are forming a quadratic equation. And this quadratic equation, we are going to solve it. Upon solving the quadratic, we are going to get two answers, or X is equals to minus 3. So you can see we are talking of measurement. There's no way we can take a negative value. So the correct value of X now in this case is going to be 18. Then now, once you have done that, the next question that we were supposed to work out here is to determine or to calculate the angle between Q and the resultant force. So here we can now use sine rule so that we can be able to find that angle. And since you can see Q and R forms an angle that is greater than 180, is an obtuse angle, then now an equivalent of sine 52 is 128. So that's why you can see, after getting 52 from sine rule, I went ahead to do the calculation of this 180 minus 52 to get the final answer. So this is now the angle that we are talking about here, that angle there, 128 degrees, the angle between Q and the resultant force. All right, so question 5. Now we are moving to unit vectors. You can be able to be asked questions that looks like this. We are told that two boats, A and B, each are moving with a constant acceleration. And remember, from the Suvart equations, under constant acceleration, we have V is equals to U plus AT. and then which means that this part that we have here is representing a vector representation of acceleration. So which means that if you want to find the magnitude of acceleration of this object A, you are going to find the magnitude of this value that we have here. So that's going to be 1 squared plus -4 squared, and the final answer becomes basically root 17. And if you work it out, you are going to get your answer, which is equivalent to what? 4.1. So we shall have our answer as 4.1, and that awards you 2 marks. When t is 2, the velocity of b is this, and when t is 5, the velocity of b is this. Now, if you are told to find the acceleration of b, it means we are going to use acceleration formula. Acceleration is equals to change in velocity divided by change in time, which is the same as A is equals to final minus initial over the change in time. So change in time will be 3 seconds, but we shall subtract the velocities there. And since we are giving our answer in terms of I and j, we are going to get our answer as -I, -2j kilometers per hour. So squared. Now we're supposed to find the velocity of b when time t is equals to 0. Now whatever we have found in this question, in the previous question, we have found what we call acceleration, but we know under constant acceleration v is equals to u plus at. So this formula is key, this formula is important. So we are going to say now that using t2, we can be able to say final velocity will be for b when times, because we need to find the velocity of b at t0. So meaning that we don't know it at the moment. So meaning we are going to say using t is equals to 2, then we can be able to say now vb, or final velocity of b, will be this. Yeah. So, but acceleration already we have it from this particular end. Then we can now say final velocity that we have mentioned here should be equal to the initial velocity of b plus acceleration times time, which is 2 seconds. So if you work it out, you are going to get the value of what? vb initial. So that's basically what we are going to do at that point. And if you are getting value from this particular video, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. Right, so moving to the next part of this question, part D, we are told that at time t1 hours afternoon, boats are moving with the same speed. Find the exact value of t. If they are moving at the same speed, it means that VA at time t equals to 1 and the VB at time equals to 1, those two speeds are equal. And if the speeds are equal, then it means that the magnitude of the unit vectors also will be equal. So that is the approach we're going to use. So we know that VA was having this equation. Initially, VA was having that equation. This one was provided. This is the equation. So we need to find VA at time t1. So VA at time t1 is going to be, we shall substitute where we have t here with t1, and then we expand, we put those terms with I and j together. So meaning that, like for instance, this one is 2i and this would be t1, so it would be 2i plus t1i. If you factor I out, you are going to get 2 plus t1i plus 3 minus 4t1j. Then we now move to VB. The equation for VB final, V is equals to U plus AT. We have already gotten the initial velocity of B, which we have gotten in the previous section here. Then we can be able to write its equation in terms of T, general equation. But if you substitute T1, the equation now becomes this, right? So at equal speed, that's what I mentioned here. At equal speed, VA equals to VB, meaning speed of A should be equal to speed of B. But since these speeds are written in terms of unit vectors, then it means the magnitude are also what? Equal. So meaning we are going to find the magnitude of VA, this squared plus this squared, and also this squared plus this squared. We equate the two guys. So if you equate the two guys, we are going to get our answer reducing to this part that we have here, which is this. But if you expand and simplify, you'll get nothing other than this particular equation. Now this is a quadratic equation, guys, which means that for you to simplify that, you can be able to simplify that by using a quadratic formula. We can solve that using a quadratic formula, and if you solve, you're going to get -1 plus root 17 over 2. Because the question asked you to write the exact value, so which means that your final answer must be in terms of SADs. Yeah, so that is exactly what you do. Now at time T2 hours, afternoon, both are moving in the same direction. So if they are moving in the same direction, it means they are parallel. And if quantities are parallel and moving the same direction, then the one is a multiple of the other, positive multiple scalar. So if you have two quantities which are parallel, two vectors which are parallel and moving in the same direction, you can be able to say they are multiples of the other, multiple of a scalar positive value when they are moving in the same direction. But if they are moving in the opposite direction, the scalar is going to be negative. So, and how do you handle that? If two vectors are parallel and in the same direction, then one is a positive scalar multiple of the other. So if V vector A and the vector B are parallel, then it means there exists a constant. If you multiply them, you get the other vector. So in such cases, when you are given questions like this, what I want you to master here is that the I component of the one vector over the I component of the other vector should be equal to the J component of the other vector of J component of vector B, which can also be given as VBJ over VBI, meaning the component of vector B, the J component of vector B over the I component of vector B should be equal to the J component of vector A divided by the I component of vector A. So we have two equations here in terms of, because they are parallel, the only part that we are going to work out, because we are talking of T2. So meaning on these equations that we are having here, VA and VB, instead of replacing T1 and T1, you are going to replace to those equations T2. So once you replace T2, you can now form the equation for VA and for VB at that particular time. And in that way, if now you take the I component of A, which is 2 plus T2, over the I component of vector B, which is 6 minus T2, is equals to the j component of this over the j component of that, then if you cross multiply and expand this, you are going to have basically a quadratic equation. And this quadratic equation can simplify because this is 6 minus 28t2 plus 8 is equal to 0. Then we can be able to divide by 2 all through, which is going to give us exactly 3t squared 2. And you can see a 3 is appearing at this point. So we were told that p and q are quantities to be found, or integers to be found. You can see it's negative 14 and also 4. Yeah, so basically that's what you need to do given a question like that in mechanics. We have also question number 6. I brought this question so that you can also review when you are given now forces in terms of I and J. How do you handle that? We are given 2 forces here, and we are told that in question number 6, particle P of mass 2 kg move under action of 2 forces. The first force is Pi plus Qj, and also we are told that the other force is 2Qi plus Pj, where P and Q are constants. Now, given that the acceleration of P is I minus J meters per second, now find the value of P and Q. This question here, we are going to use the concept of force is equals to mass times acceleration, which is Newton's second law. So meaning that first we need to know the resultant force, and the resultant force is going to be, when you are given unit form, always just take those 2 forces in unity form, add them direct. You don't do anything. Anytime you are finding the resultant force and you are given the forces in unit vectors, add them directly. And when you are adding, now you need to realize that you are adding the I component to the I component. So you are going to have P plus 2Qi plus Q plus Pj. Now this becomes our resultant force. Now once you have the resultant force, you can be able to apply the concept of force is equals to mass times what? Acceleration. And if you simplify everything that we have on the left hand side and the right hand side, we are going now to put the component I components together and J components together in either side, because now if you put them together like that, you see on the left hand side and the right hand side, you have what? You have the J and I components. So from there you can now equate the component I components and you equate the J components, and then you are going to form 2 beautiful equations, equation 1 and equation 2. So now, since we are finding the values of P and Q, and you have 2 equations from math and pure math, then it means you can now solve these 2 equations simultaneously. And I used elimination method here by subtracting equation 2 from equation 1 to eliminate P. And in that way, I got my value of Q to be 4. And then upon substituting the value of Q, which is 4, into equation 2, I got my P equals to -6, like that. So basically, that's what we are supposed to do in this question. Find the size of angle between the direction of acceleration vector J. So acceleration is this. That was the vector, the vector form of that. And if you plot this to be I negative J, so that point is going to be down here. So meaning that if we want to find that direction, that angle from J is at the top here. So the angle that we need is this angle up to that point. But for us to find that angle, we need first to work out this angle theta down here, because this is I and this J, so meaning this is 1 and this is also 1 here. So we have a right angle triangle, so meaning that we can be able to use SOHCAHTOA. So tan, for us to find theta, it will be tan inverse of 1, because 1 over 1 is going to be 1, so that is going to be 45. 45 degrees. But since we want an angle from J, we are going to take 90 degrees plus 45, and that is going to give us 135 degrees as the required value. So basically that's what you do. Then we have the last question that is going to be the last question of this particular part. This is part 1, so check a link in the description. You'll be able to access part 2 of this paper. Now we are being told that at time t is equals to 0, the velocity of p is 3I minus 4j. At time t is equals to 0, velocity of p is equals to 3I minus 4j. And at time t equals to t seconds, p is moving in the same direction. That question is related to this question that we have already done here. So if we are trying to work out that, the first thing that we need to identify is that we are using v is equals to u plus what? Plus at. And this is going to be used in the sense that since we know the initial speed of this, so meaning, and we know the acceleration, then we can be able to write the equation for the final velocity of p, which will be moving in the same direction to this one that we are given here. So once we have gotten that, because time that we shall acceleration, we know it's I minus j, but time we shall use t, then we can simplify that to be 3 plus t I plus, we have here plus minus 4 minus t j. Okay, so upon working out this in the same direction, means they are what? They are parallel. Already we had mentioned that, and we said if they are parallel and in the same direction, then the k constant must be a positive value. But if they are in opposite direction, you'll have to add you say one is the negative of the other. You must add a negative on one when you are basically putting these ratios. You add a negative there. But in this case, since they are moving the same direction, you just take components of one of the vector I over j, like that. Just the way we did it here. So let's see how we go about that. We have this, so we are going to say, therefore, since they are parallel, we have the component of I is 11 here. So let's start with I. 3 plus t over, this is the I component, should be divided by the I component of this, should be equals to negative 4 minus t over negative 3j, negative 3. So if you cross multiply here and simplify, you'll get your final answer as 2.5 as the value of t. We have more questions that we're going to work out. Just check in the description below. You're going to have a look at how we did this question here. Also, you'll have a look at how you'll handle a question like that. Also, we shall have connected particles, shall have questions there. You'll also be working on a question that looks like this. So those are the kind of question we shall be looking at, and I'm trying to check if I can be able to see where this paper is, so that I can be able to show you the remaining question that you need to check in the description and get to see how to go about them. And guys, if you are new to Proflearn YouTube channel, consider subscribing, so that anytime I'm going to do more tutorials, you'll be notified. And then remember to share this video to your friends, encourage them to join Proflearn. Yeah, so I think I've accessed the paper so that you can be able to see the question that you'll be working on, we shall be working on. Yeah, so just download the paper from our Patreon page so that you can be able to work on them. Good luck, guys, and all the best in your coming exam. Yeah, so we shall also do questions which involve friction, rough surfaces. We shall also have questions to do with moment, because already we have done momentum. We shall do questions like this. Just check the link in the description so that you can be able to see how you are supposed to work out questions that looks like that.